Okay, we're going to take a look now at factoring trinomial squares. And if you remember back from Unit 4 in the multiplying part, okay, basically you start with a binomial squared, and then what you do, right, this x plus 3 squared, if you remember the shortcuts, okay, you square the first one, so x squared, you square the last one, so plus 9, and then what you do is you multiply the two terms together and multiply that times 2, so you end up with 6x in the middle. Okay. For the last second one over here, x minus 3 squared, we're going to do x squared. We're going to do plus 9 because negative 3 times negative 3 is positive 9. Okay, and then negative 3 times x is negative 3x times 2 is negative 6x. Okay, so hopefully you remember those shortcuts. If not, remember the other way you could do it is just to write them out like normal. So you could have done like x minus 3 times x minus 3 and then just factored it, or just multiplied it, okay? And that would have been fine. You got the same answer. Okay. Now, when we're talking about factoring them, okay, here are the things that you need to look for, okay? And you'll notice it in both the equations that we have. Okay, first of all, you need to notice that there are, first of all, one perfect square and then a second perfect square. Okay, and remember, perfect squares can only be positive. So if either one of the perfect squares are negative, this isn't going to work. Okay, so you can't do it with this. So in both of these problems that we have here, both of our perfect squares are positive. So even if you flipped them around, you would look for perfect squares that are positive. Okay, and then what you have to look for is if you take the middle term, okay, the middle term there in both of these, you take the factors of, or you take the roots of both of the two outside ones, so x and 3, and if you multiply those two together and multiply it times 2, then you're going to get the middle term. Okay? Now on the one on the right, that works. We get x and 3, and you multiply it times 2, you get 6, but we have negative. Okay? Well, that works as well. So it's called the additive inverse, and that's all right. So the middle term can be negative, the outside ones, or the perfect squares can't be negative. Okay. Okay, so if we were going to just figure out if these are trinomial squares, the answer to that would be yes, because we do have, okay, our first term is a square and it's positive. The second one, the last one is a square and it's positive, and the middle is the root of the two squares multiplied together and then multiplied times 2 or times negative 2. Okay, it'll work either way. Alright, so we're on page 6 of your notes if you haven't figured that out already. And the example at the bottom is what we just did right there. Okay, so we're now flipping over to page 7. Okay, and on page 7, number 2, it says, is x squared plus 6x plus 11 a trinomial squared? Okay, and so you go through that checklist. First, do we have two perfect squares in here? Okay, well, we have x squared, that's a perfect square, and it's positive. But we don't have another one. Okay, this 11 is not a perfect square. So no, it is not a trinomial squared. Okay, so you're done. So that's as simple as that. Okay, no, that's not a trinomial square. Okay, so let's look now. Okay, let's look now at this third one. So number 3, it says, is 16a squared minus 56ab plus 49b squared a trinomial squared? Alright, so the first question, are there two perfect squares? Okay, well, 16a squared, yes, that's a perfect square, and it's positive. 49b squared, yes, that's a perfect square, and it's positive. Okay, now, the middle term, okay, is it the root of the two outsides? So the root of the first outside is going to be 4a, and the root of the last one is going to be 7b. Okay, so let's multiply those two together. We get 28 AB, and then if you multiply it either by 2 or negative 2, do you get the middle term? And if we multiply that together, we get negative 56AB, which is the middle part. So yes, this is a trinomial square. Okay, so that's perfect. That's exactly what you're looking for. Okay, so the root of the first term, the root of the last term, multiply them together, multiply that by either 2 or negative 2, and that will tell you if you have a trinomial square. Okay? Alright, so there's some try these down there. Give those a shot really quick, and then all you got to put on these is yes or no, that they are a trinomial square or they're not, and then come back and we'll do them together. Alright, so let's take a look at these, try these. So the first one, okay, do we have two perfect squares? We do. We have x squared, and that's positive, and we have 16, and that's positive. And then the square root of x squared is x, the square root of 16 is 4. Okay, if we multiply those two together, we get 4x, and then we multiply it times 2, and we get 8x. So the answer is yes, it is a trinomial. We are good. Okay, trinomial square. Alright, the next one. X squared minus 12x plus 4. Okay, so square root of x squared is x, square root of 4 is 2. Multiply those two together, we get 2 times 2, that gives us 4x. Okay, or we would probably do it by negative 2 here because we got the negative in the middle. The outside terms are correct, but the inside term doesn't make it work, so that's a no. Alright, let's look at the next one. So we have 4x squared, so that's going to be 2x, and then 25 is 5. And then if you multiply those two together, you get 10 times 2 is going to be 20. So this is a yes for the third one. Okay? And just so you know, when we're working these out, and I'm writing this down below, we're really close to actually being able to factor these, so we're pretty close. Alright, the next one, we have 9x squared, so that's 3x is its root. 16 is 4. Okay, and so we multiply those two together, and that gives us 12x, and then times 2 is 24, so that's a no for this one. Okay, that's not the right number. And then finally, this last one down here, okay, 16x squared, that's going to be 4x, and the last one is 5y. If we multiply 4x times 5y, that gives us 20xy, and then times 2, that's 40xy. So the last one is a yes. Okay, so now you know how to tell whether or not they are trinomial squares. So we're on a good path here. Now we're going to go into how to actually factor them, and we're almost there already, which is what we just did. Okay, when we talk about factoring these, at the bottom of the page 7, they do have the a squared plus 2ab plus b squared, and how it equals. I'll show you here. A squared plus 2ab plus b squared equals, and the square root of that, or the trinomial square, the factor out of it, is going to give you a and b. Okay, and then what you do to find your answer is you take the sign of the middle term and put it in between. Okay, that's your shortcut to getting your answer, and then you put it as squared, and you're done. Okay, and then you have a squared minus 2ab plus b squared. And so we have the square root of a squared is a, the square root of b squared is b. We're going to square this, and then because the sign in the middle is negative, we're going to make this negative. Okay, and when you add the two together, you get a negative middle. Okay, but when you multiply them together, right, you get the positive on the end, so that works out good. All right, so there's your trick right there. Okay, you take the square root of the first term, square root of the last term, and then you put the sign of the term in the middle if it is a trinomial square. Okay, so let's look at some examples here. All right, so we have x squared plus 6x plus 9. Okay, so it is a trinomial square because we have a square, and the middle works. So the square root of x squared is x, square root of 9 is 3, and we put the sign of the middle term, so it's going to be plus, and our square, and we're done. Okay, And if you multiply that to figure it out, 3 times x is 3x times 2 is 6x, so that's the middle. We're good. Okay, we have x squared minus 14x plus 49. So if you look here, we got x for the first term, 7 for the second term, and then we're going to go with a negative there and make it squared. So we're good there. All right. The next one, we have 16a squared minus 40ab plus 25b squared. So let's break it down. 16a squared, that's going to become 4a. 25b squared is 5b. And then your sign in the middle is negative, so there you go. And there's your answer. Okay? Okay, and here we go with the next one. We have 27m squared plus 72mn plus, oh, wrong number, sorry. Read the wrong question there. And plus 48, I'm going to shrink this down a little bit and move it over. There we go. Plus 48n squared. Okay, and so you put those together. Okay, does this work? Well, darn it, 27 is not a perfect square, and neither is 48, so that's not going to work. Well, what can we do? Well, let's go back to our steps. Okay, what's the first step that we're supposed to do when we're factoring? We're supposed to look for a common factor first, right? So what would a common factor be of this problem? Okay, well, the common factor is 3. Okay, so we're going to factor out this 3 first. When we factor that out, we get 9m squared. We get plus 24mn and plus 16n squared. Okay, and now if you look, perfect square in the front, perfect square in the back, we're in good shape. Okay, so now it's 3 times the quantity of 3m and 4n, and our sign in the middle is positive. Okay, so make sure you're always checking, okay, follow the steps that we've done. I put them in order like this on the website for a reason, right? First thing you do, you look for common factors. Second thing you do, you look to see if it's a difference of 2 squares, and then you look for a trinomial squared. Okay, all right, so you got some try these there. Give those a shot really fast. Okay, sounds like your kids are going to come back to class really quick, so I better get moving here. All right, so we have x squared and we have 1, and 1 is a perfect square, don't forget that. So we have x and we have 1, and we have a plus in the middle, so we're squared. Okay, this time, again, x and 1, but this time we have the negative in the middle, so we're going to make it minus and square it. Okay, next one. Can we factor out a common factor? No, we can't. All right, so, and we have perfect squares already, so we're good. So 5x and 7, and our sign in the middle is negative, and we're going to square it, so we're good. All right, and on this last problem here, if you look first, we don't have perfect squares, so I'm looking for greatest common factor, and that is going to be 3. Okay, and if you pull out the 3, you get 16m squared plus 40mn plus 25n squared. And now we have perfect squares, so then we do 3 times, we got 4m, and we have 5n, and the sign in the middle is positive. And there we go. So your final answer is kind of ugly, but 3 times the quantity 4m plus 5n squared. All right, so go ahead and do the worksheets that go along with this. Hopefully it makes sense. Work with your team. Talk to you later.